about, we finished this, I believe, right? We were talking about sets, and we did that example about words in books. All right, debugging. Raise your hand if you've debugged before. Of course you have, right? Silly question. Because that's mostly what programming is, fixing all the mistakes you made. And hopefully by this point in the semester, like earlier in the semester when I was saying like, oh, most of programming is debugging, you're thinking, haha, okay, we're gonna be debugging a lot. Raise your hand if at this point in the semester you're like, oh, he wasn't lying. That's correct. That wasn't, yeah, exactly. That's most of what it is. And that's not because you're new. That's because you're programming. It doesn't matter if you've been programming for decades or you've been programming for weeks. That's what it is. It's just what you spend your time debugging is going to be a little different, but you're still debugging. So if you're thinking, I suck at this because I'm debugging most of the time. No, that's just what it is. It's not because you suck. It's because it's the way it is. So obviously, debugging is important because it's important that you get your stuff working, right? But there's a couple other aspects of debugging. Like there's a couple of other things about debugging that's just really good, right? Is it really, when you write code, okay, first of all, we gotta understand the bugs could be popping up in there's a lot of different types of bugs, but there's two core areas where bugs are gonna pop up. Remember the process of programming. If you're thinking, I read the problem, I sit down and code, you're doing it wrong. And I'm not just saying, oh, you should do it the other way. I mean, if you don't stop doing it that way, you're never gonna be successful. You need to first read the problem, understand the problem, come up with the idea in your head, the algorithm. But remember, the algorithm is not the code. Those are two different things. So you look at the problem and you come up with an algorithm, your way of solving the problem. And then you take your algorithm and you implement it, you code it. When you have a bug, the bug is either going to be a consequence of your implementation of your idea, or it could be because of your idea. Did the bug come from here to here, or from here to here? Be aware of that. Like, what I mean is if you're looking at your code and you're looking, well, where's the bug? Maybe the bug isn't even really in the code, but it's with the algorithm in general, which ultimately it's then in the code, but it's important to differentiate those two steps. And when doing that, when looking at a problem and studying it and fixing your code, you're going to get a much better understanding of the algorithms you're working with because you're debugging them. You need to understand them really well, the intricacy, the nuance, to get them working. At this stage of the game, if things have been going well in the course, you know the amount of effort you need to put into being precise is really high. If you sit down, I'm getting concerned because sometimes I'll be at lab and sometimes I'll be in student hours and people will show me their code. For the most part, when people are showing me their code, a lot of times at this stage of the game, I can see students, they're coming, and I can see what they have, and I can be like, you have it all there, you just haven't aligned it quite right. So you're right, you're so close to being right, which is always a good thing. Those are good problems, those are good issues that you're having from my perspective because, like, obviously you don't want these bugs. But to me, I go like, I know you know what you want to do. That's a good thing. Concerned is when I look at your code and I go, I don't think you even know what you want to do. That's when I go, okay, this person's, if they don't get it together yesterday, they're in trouble. Now, for the most part, chances are if you're here today and you're not here today, you're probably fine. But that happens a lot. And sometimes I'll see people write lines of code that I don't even understand what they do. And I'm pretty sure they don't either. So when I see that, I go like, you're not even being precise. Like, you're not even being careful about what you're writing. And if that's the way you're going about doing this, you're never going to succeed. Because you need to be slow, methodical, careful, write one line, did it do what I want it to do? If you sit down, write a 7-line function and hit run and goes, it doesn't work. Yeah, start over. Don't try to debug it, start over. You're wasting everyone's time if you're trying to do that. That's not how to code, and I've been telling you that since day one. You write a little bit, make sure it did what you want it to do. Write a little bit more, make sure it keeps doing what you want it to do. Take your time. So when you are taking your time and you're thinking about this code, sometimes people will come to me at office hours, student hours, and they'll say to me, or maybe I'll get an email, and I'm pretty sure none of these people are in this room right now because I'm recognizing the names at this point in the semester. But I'll see, like, I've been working on this assignment for hours and I just can't make any progress, right? And, well, first and foremost, sometimes people will come and they'll be like, I'm stuck on the assignment. And I go, okay, well, what are you stuck on? They're like, well, the beginning. I go like, well, what have you done? Well, nothing. Well, go do something. I can't help you if you haven't done anything. I'm like, well, I don't even know where to start. Never say that to your prof, because that's a coded language of saying, I've done nothing, I've tried nothing. I don't know where to start. At the beginning, that's where you start. And if I need to tell you that, so yeah, here's a tip. Don't say that to your prof. If you say that to your prof, you're immediately going to lose a lot of points. But back to the point. These assignments are intended to take hours. Raise your hand if you're done assignment 2. Okay, raise your hand if you're like, okay, I'm kind of done assignment 2. How long would you say you spent on it so far? It's hard to say, right? Because you probably did a little here, a little there, a little here, a little there. You know what? That's a good strategy. In fact, here's my tip to you. And I'm like, here's my golden advice to you about how to do assignments in programming. You get the assignment. The first thing you do is you read it. And then you read it again. And then your job for the next week is to not think about code at all. I'm not joking. Don't think about it at all. And this strategy won't work if you're like, oh, I'm going to do what he's telling me to do starting now for assignment 2. No, it's too late. You're screwed. The advice works for when an assignment comes out, you read it and you understand it. You spend a week thinking about it. But of course, when I say you spend a week thinking about it, I don't mean you sit down in your room and you go, No, that's stupid. No one works like that. You don't just sit there going, I'm thinking now. No, what you do is when you're walking to the university, maybe you're thinking about it. You're watching hockey, maybe you're thinking about it a little bit. You're in the shower, maybe you're thinking about it a little bit. Just think about it passively. Just let the ideas brew and think about it passively. And the next thing you know, honestly, before you know it, you've got a full solution in your head. Now, your full solution might not be accurate, it might not be perfect, but you work on it. Once you're comfortable, once you're like, yeah, I've got an idea, you start implementing it. And maybe you get like an hour in and then you realize, oh, something's not quite right. Okay. Sometimes the best thing you can do for debugging, I'm not joking, this is a meme, where you can it's 8 p.m. and you're working on your assignment. And this strategy obviously isn't going to work if it's due at midnight. But you're working on your assignment, it's 8 p.m. You have a choice. You hit a bug and it's a tricky bug. Maybe you've been looking for the bug for 20 minutes or something and it's just not quite right. You have a choice. You could spend the next 4 hours tracking down that bug, or you can stop, go to sleep, try again tomorrow, And often, the number of times this has happened to me is like you'll wake up the next morning and you're like, yeah, I know. You don't even need to look at your code. You go, I know what's wrong. Sometimes the best thing you can do is step away. And I need you to understand that I'm giving you like golden advice right now. I need to tell this to the other section. They're missing out. When you give yourself time to think, you come up with your algorithm, you think passively, you've got your ideas in your head, and then all you have to do is implement it. I realize at this stage you're still learning a lot of programming, so implementing it is not trivial. I get that. But it's going to be a hell of a lot easier to implement when you've got a working solution in your head, or close to a working solution in your head. So that's the good strategy for going about solving these problems. And that's why it's hard to say how long it takes. But like if you've spent less than 4 hours on an assignment, and you come to me saying, oh, I've spent hours and I don't know what to do, I'm gonna to me it's a little laughable. Now, if you've spent less than 4 hours and you're stuck on part 1 and something's kind of yeah, come see me. But don't come see me saying like, I've already spent 4 hours, this is outrageous, I can't believe it, this is too hard or something. I go like, if you think that you're gonna get this done in 4 hours, like who told you that? And it's funny because you could take a course where you have to write an essay, and if you go to your prof saying, I spent less than 4 hours writing this, I've spent less than 4 hours total dedicated to writing this essay, they're gonna say, okay, it's gonna be a shitty essay. Everyone kind of knows it's gonna take a while to write an essay. Everyone thinks they should be able to sit down and finish a coding assignment in 20 minutes. No, it's gonna take 8 hours. Right? Like that's normal. This is not to scare you. This is not to make anyone feel bad. No. This is to give you a correct perspective on what to expect. And this is, if anything, is supposed to be motivating. So if you found this demotivating, you're thinking about this wrong. No. Be prepared to have it take a little while. But during this time of thinking about your code, and I'm counting that towards the 8 hours. I don't mean sitting in front of your computer bashing your head against the keyboard for 8 hours. No, I mean in total. But when you're thinking about it, you come up with your algorithm, you go to implement it, and maybe the algorithm you came up wasn't quite right. Or maybe it was right, but you implemented it wrong. But when you're teasing all this out and you're debugging, you're going to get a way better understanding of these algorithms. And next time you need to do something similar, you've already got that algorithm up here. You just take it out and change it a little bit and you're good to go. That's what that's the skills experienced programmers have, is the problem you're solving today that you've never solved before, they probably encountered that problem 20 years ago and encountered that same problem dozens of times since then. So they know how to solve that problem just because they've done it so often. The difference between you and them is time. That's it. They're not better than you because they're better than you. They're better than you because they've been doing it for 20 years. Maybe 20 years from now, you'll be way better than they were at that point. Remember that. And that goes for everything, right? You're young. So remember that. Just because someone has a little bit more experience than you at anything, they have more experience than you. Listen to them. But it doesn't mean that they're a genius. It just means that they've been doing it for decades longer than you have. Maybe decades from now, you'll be better than them. Maybe not, who knows, whatever. It doesn't matter. Just remember that. It's just about time and experience. Anyways, more about debugging. So you're going to be, all of that was to emphasize the point, like, yeah, you gain experience learning about these algorithms that you're going to be using a bunch if you continue to program. You're going to learn a lot more about your specific programming languages. You're going to be able to think really logically and slowly and step by step about your code. And that's a big thing too. When I'm sometimes in lab, I'll ask someone, they'll be like, something's not quite working. And I'll squat down and I'll sit next to them and be like, okay, well, I'll often ask, tell me what this code is doing line by line. And 9 times out of 10, someone will be like, well, I wrote a function that does X, Y, Z. I'm like, well, no, line by line. Okay, well, these 3 lines here, no, line by line. And I think they think I'm doing it. Like, listen carefully. I want you to listen to me. I think people think I'm doing it to be like demeaning. Like, oh, you're so stupid, you have to do it line by line. No, you need to be that stupid to do it line by line to be good at programming. I'm not calling you stupid. I'm saying you're trying to be too smart. You need to dumb it down and do it line by line because that's what programming is. So when I'm going over line by line and you're like, oh, line by line, I feel like I'm in kindergarten. No, that's what you do. You have to be able to understand what does each line do. And there's a trick. Never make a single assumption. Let me ask you, how many times, and maybe not a lot yet because you're still relatively new at this, but I'm willing to bet some people in this room will know what I say. How many times have you spent a while debugging a chunk of code only to discover that the issue was somewhere else, maybe a little bit before, and the issue was really just because you assumed something was the case beforehand? So the issue is here, but every time you're like, well, this chunk of code does this. And the issue must be here. So you spend all this time looking over here, only to later go like, oh, I assumed it was A, but it should have been B. Has that happened to anyone yet, where really the issue was somewhere else and it was just because you assumed something about your code? Yeah, a bunch of people are nodding, shaking your head. Yeah, yep, absolutely. Line by line, make no assumptions, take it easy. Okay, bugs. Sometimes, who here has ever hit run and got a syntax error? Of course. Now, syntax errors are relatively simple to figure out because most of the time Python kind of shows you, right? It'll give you an error message, and look at that one, invalid syntax. It's even like showing you. It's saying line 17, see right here? See how you've got that little extra plus? That's invalid. It's telling you. Great, awesome. So those are relatively simple to debug. But sometimes those error messages are quite cryptic. But when they're cryptic, raise your hand if you've ever copied that error message that you didn't quite understand, threw it into Google and found a solution. Raise your hand really high, I want to see. Of course, of course. And you know what? Here's the secret. That's programming. Going, I don't know what this means. That's what it means, right? And how many times have you copied an error message and you still didn't quite understand what the error message meant, but maybe you found it on Stack Overflow or something, but you found someone's solution to address that error message there? Yeah, that's programming. And you might think, oh, that's kind of cheesy. Am I cheating? Well, okay, I get where your concern is. And it could be borderline cheating, but if you're doing this the right way, it absolutely is not cheating. What you're doing is like code refactoring, which is a really good thing. If you can do this, you're good at this. If you can do the following, and you're very confident in that you have done the following and you can do the following, I can tell you right now you're going to be really successful programmers. If you can look at your problem, and maybe you don't quite understand the error message, but like you've got a sense of what's wrong with your code. You know what you want to do, right? You've got your problem. You know what you want to do. You know what you've been trying to do. Like, here's my code. It's not quite working. So you do some digging around on Google, and you find someone's solution. But here's the thing. No one has the exact same problem you have. That'll be the case maybe up until now. Some of the problems you're going to interact with are small enough that other people may have run into the exact same thing. But we're getting to the stage of the game where they're going to have a solution to the same underlying problem, but the context that they're trying to solve the problem in is entirely different. And chances are maybe the problem isn't exactly the same. It's similar. But you can see that their solution to the problem, because if you're on Stack Overflow, you know, it always starts with like, here's my problem. Then if you scroll down, it'll be like, well, here's a solution and here's why. Here's a solution and here's why, right? So maybe you've got your problem, you understand your problem, and it's not working. You go find someone else's similar problem and their solution. You take it to make it work with what you're doing, and it's good to go. Raise your hand if you've done that, more or less. Raise your hand really high. Okay. If you keep doing this type of stuff, if you keep at this, I know every single one of you is going to be a good programmer. And if you're not really successful in this course, it's not because you didn't have the skills. No, you've got the skills. That right there, in computer science, pedagogy. Pedagogy is this fancy word to mean like how to teach computer science and what to look for. One of the number one things, if not the number one thing, that you look for as like a prof and students is code refactoring. What I mean here is, that's a broad word, but in the context of what I'm discussing right now, what I mean is, you know your problem. You know what you're trying to do. You've implemented, it's not working, and you've got a sense of why it's not working. You find someone else's solution, but it's not quite the same. But in order for you to, uh-oh, was that your computer? It's all good? Oh, oof, it's always scary. You ruined my story. So, if you look at someone else's solution, and you can see, you're first going to have to know what are they trying to do. You have to be able to know what they're trying to do to recognize that it's relevant. So you're able to look at someone else's code and know what it's doing. You're able to understand their problem. You're able to understand why what they changed fixed it. Let's be honest, sometimes you don't. Sometimes you copy paste, you hope for the best and it works and you go, all right, whatever. I get that. But in general, it's not going to work like that. You're going to have to understand their problem, understand how they were trying to solve it, understand why the change fixed it. You take that change and you have to change their change. You have to modify what you're taking a little bit to work for you. And if it works, that should demonstrate to yourself that you know what the hell you're doing. The amount of deep understanding you have to have in computer science to be able to do that effectively is really high. So if you can do it, you're crushing it. Keep up the good work. And I'm going to tell you right now, if you've been giving yourself the scapegoat of, well, if you're not happy with how well you're doing in the course, if you raise your hand that you've been doing that and you've been doing that effectively, but you're unhappy with how you're doing in the course, and you've been using the scapegoat, I guess I'm just not good at it, you can't use that one. Because you are good at it, whether you like it or not. You do understand it, whether you like it or not. So there's another excuse you got to find for why you're not doing well. Again, not demotivating, motivating, right? Right? Okay, syntax errors. Here's usually my strategy for dealing with syntax errors. Is, maybe I could look right at this, and I could go try to fix it, or I can go, it was never closed. Oh, I see the issue I had. I didn't close my parenthesis. Let's run it again. Oh, what's wrong? Oh, it looks like maybe it's def with a single F, yeah. Oh, no, I missed a colon, all right. No, what's wrong? Oh, plus, right, I don't know how that got there. What? How many of you run into this problem? You're like, no, it's right there. What are you telling me it's not defined? It's right there. Oh, it's spelled wrong. Raise your hand. Everyone put up your hand. I know you've done it. You want to know the best part is when I made this example originally, that wasn't on purpose. And then what is this? What's wall? Oh, it's not right. It's nonsense. What's that doing there? But look, the amount of actual critical thinking I needed to fix this issue was very low. Sure, I needed to know what was wrong about it once the error message was shown to me, but I just did what Python told me to fix it, right? Now, type errors. Any questions about syntax errors? Raise your hand if you've ever had them before. Yeah, there you go. That's what I thought. Of course you have. We all have those. Type errors. Now, Python is pretty good at figuring out types. If I say a equals 5, Python goes, well, 5 is an integer, so a should be a variable for an integer, so I know a is an integer. Great. Because every value has a type. But Python can only do so much. Like if I were to see, look in this example where a and b. A is 5, b is 5.5. So a is clearly an integer and b is clearly a float. And when I say add them together, Python's like, okay, they're different types. I can add an integer and a float together. Now, when you add an integer and a float together, it knows, like, okay, let's think about this for a second. I'm adding an integer and a float. An integer doesn't have decimals. A float does have decimals. So if I'm adding them together, what should the type be? Like, what would be a rational, reasonable thing to have the type be for the thing that's returned from that? Well, a float. Because if it's an integer, you might lose, like, precision, right? So if I have an integer and an integer, yeah, I'll give you back an integer. An integer and a float, let's go with a float. And if you really want it to be an integer, you can change it to an integer later, that's fine. But if you're adding a float and an integer, you should probably, Python's going to figure some of that out for you. But it can only do so much, because if I ask you what's hello plus 5, what do you say? You go, that's not a thing. And so does Python. It's going to say, I can't add a string and a float together, or an integer together. That doesn't make any sense, because it doesn't. And the reason Python isn't going to go, well, obviously they meant it to be a string, right? Obviously, if they added a string and a float together, or a string and an integer together, they wanted to concatenate strings. Did you, though? It's probably pretty safe for Python to assume that if you're adding an integer and a float, you want a number back. But it's not really safe for Python to assume what you wanted in general. So when you add a string and an integer, and you're like, well, obviously I wanted it to concatenate, then tell it. Because maybe you didn't. Maybe it was a typo. And it's probably better, if there's any ambiguity, it's better for Python to not run with a potential bug. There's an ambiguous situation. Should Python, let's think about this reasonably here. And maybe you've had the opposite thought, but let's think about this. What do you think is the smarter, safer thing to do? You give Python an ambiguous situation. They want to add a string and a float together. Do they really? So Python's not quite sure what you really want. So what's safer for it to do? Is it safer to go, I'm not going to run that. And if you want to convert it to a string, go ahead and add them together. Or is it safer to go, sure, I'll add them together, I'll just assume what you wanted. Obviously, the latter is a stupid idea. That's not really safe at all. I could get why someone might think at first, like, come on, obviously that's what I meant. But now that you've been programming enough, I think you're experienced enough to know, like, yeah, that's probably not a good idea, right? So if you really wanted, if you're like, but I really wanted to add a string and an integer together in order to, like, concatenate strings, then write the code to do that. Simple. Don't make Python make that assumption, because it's risky. In fact, Python does make assumptions about the types for you. And new programmers are often like, yeah, it's great. But remember that example I was showing you? If I call inconsistent with the number 1 and 1, it gives me back 2. If I call inconsistent with the string 1 and 1, it gives me back 11. If I was reading input, how many of you have accidentally, when working on caddis problems, forgot to convert your integers like that were read into strings back to integers? Of course you have, right? And Python will let you make that mistake. Python will be like, okay, cool, I'll run it. I'm doing what you told me to do. Because it's like, obviously you read it in, so obviously you wanted it to be a string, right? So it's assuming you really wanted it to be a string. It's assuming what you wanted. And it's going to run. But there's other programming languages where it will not make such assumptions like this. These are more, we'll call them like more strongly typed languages. Java, what we're going to do next semester, is a more strongly typed language, where you have to be very explicit and careful about the types. And you might, if you're thinking for a second like, oh, it's more restrictive. I have to do more work to make it more restrictive. First of all, it's not more work. But two, I would argue it's better to have incorrect code not run than it is for it to run with the incorrectness existing silently. Because this type of issue, imagine I've got two sensors. I'm not inputting the numbers. There's two sensors that are reading temperatures or something. I don't know. And you give those two values, two float numbers that were read from the sensors as strings. And you gave it to inconsistent. And it outputs another number. If I run that program and I see the sum of those two sensors, then I go like, oh, it's 11. Okay, I guess the sum of the two things that were read in came up to be 11. But in reality, the sum of those two things should have been 2. But I won't know. I won't know unless I go and I decide I should double check the inputs, see what they really were. Because with something as simple as this function, why would I assume there's anything wrong here? Because the issue is with the types, not really your logic. I've got these two sensors, it tells me their sum, the sum comes back at 11, I go like, that's reasonable, that makes sense. I could have ran all these assert tests on this, assuming that it was all integers and they'd all pass. So I'd assume everything is fine. But in reality, it's not, because we have a type issue here. It's acting on types. And this can be very problematic. And Python is happy to do this mistake for you. It's really happy. Because you said, add these two strings together, and Python goes, okay, yeah, cool. It's doing what you asked it. In Java, if you say, in Java, if I wrote this function, I would have to specify, before anything, I would have to specify what is the type of A and B. This function takes two parameters, but you can't just say two parameters. You have to specify what's the type. Now in Python, we've kind of been doing that with type hints. But type hints are not enforced. Type hints are just for the programmer. In Java, those type hints aren't type hints. They are part of the code. So if you have a function that you say is going to take two integers, and you give it two strings, it's not even going to run the code in the first place. It's going to say, I can't do that. This is a function that takes two integers, and you gave me two strings. I'm not going to do it. So it's not very easy to make that same mistake in a more strongly typed language. This dynamic typing that Python has, where it figures out the types for you, often new programmers thinks it's great. Experienced programmers, this is probably one of the number one things they hate about Python. There are a couple of cliche things experienced programmers really don't like about Python, and that's definitely one of them. They wish it was strongly typed. Anyways. Any questions about any of that? Okay, logic errors. Now these are the big ones. These are the tricky ones. These are the ones where you hit run, everything worked, but it didn't. I hit run, the code executed, but it wasn't quite right. Now, these are the types of bugs that our assert tests are trying to find, trying to distill for you. Where if everything worked correctly, this is based on these arguments, you should get this return value. Based on those arguments, you should get that return value. So those assert tests are to help with the logic errors, but there's no guarantee. Those assert tests can only do so much. Like on your assignments, if your code passes all the assert tests, you're probably right, but there's no real guarantee. There could be some funny little case where something goes wrong. So, yeah. And a lot of times too, have I used the word edge case before? Yeah, so in edge case, so maybe everything works correctly most of the time, but in some funny little like edge case, it doesn't. And an edge case would be an example of like, if you wrote a function that says add up all the numbers between 0 and n, and that function worked all the time, except when you gave it like the argument 0. So add up all the numbers between 0 and 0, and maybe it gave you back the number 1. And you're like, But when you gave it 1, it gave you 1. When you gave it 2, it gave you 3. So it worked in all other cases, but that edge case, something funny happened there. And edge cases, if you go look at those assert tests, a lot of those, assuming there are edge cases on the particular function you're writing, you'll notice a lot of those assert tests are actually focused on around the edge cases, because those are the sneaky ones. Those are the ones that'll get you. And it's always funny because students, when they're like new programmers, they'll be like, well, okay, fine, but my function was mostly right. If it's mostly right, is it right? No. There's no, like, what's the saying? Close only counts in horseshoes or something like that? What is it? What's the actual saying? I haven't thought of that saying in ages. Horseshoes and hand grenades, right, that's right. How did I forget that part of it? That's the funny part. Right. No, if it's not right, it's not right. Obviously, a somewhat working solution is better than no solution, but if I want a working solution, I want a working solution. Okay, cool. Now, these bugs are tricky to find, but chances are, by this stage of the semester, you've all kind of started to develop your own strategy, your own like coping mechanism, for lack of a better term, of how you deal with this. I'm going to talk about 3, 4 ones that people will often talk about. I wouldn't be surprised if what you've already been doing is one or some combination of these things. The reason I'm showing you these things is not because you should say, oh, I should do delta debugging. That's not what I'm saying. What I'm saying is here are some strategies people use that people will talk about. Do whatever works for you. But the only person who can answer like what works for you is you, right? So be aware of that. Now, first and foremost is the best way to debug is to not have any bugs in the first place, right? Which is, of course, one of the most obnoxious things someone can say. Like, you know, although it's true, like abstinence is the best form of protection. You're like, okay, all right, fine. But anyways, I got to write code. There's going to be bugs. So I'm not saying this for any other reason, though, than there are there are strategies for when you're writing code in the first place to hedge against having bugs. And these are things like write a line or two, test it. Add another line, test it. Add another line, test it. Sure, you'll have a little bug when you add a new line, but those are trivial usually to fix, usually. If you write a function and you test it and it doesn't work, okay, you got a bug. And it's not going to be trivial to debug. If you're lucky, maybe it is, but a lot of times it's not. So what do? But just my point being, though, originally, the best way to debug is to not have any bugs in the first place. The strategy of writing your code in the first place can hedge against having a lot of those bugs. That's all I mean by that. So here is, honestly, my most common strategy. This is probably the most common first strategy a programmer throws. And if you've been doing this, good. If you haven't been doing this, why not? Now is the perfect time to start because it will absolutely help. The bugs in your code are going to happen with values, usually, right? If you've got a big bug, like you've got an if statement where there should be a while loop, okay, that's maybe a bit of a bigger issue. But most of the time, and the print strategy will work here for that too with the while and the if. But assuming that you're not way out in left field when you should be over there trying to write your code and debug it, the issues you're going to have are going to be with the values of your variables that you're working with. And something's not quite right. I hit run, this function should have given me 77, it gave me 41. What's going on? So that then begs the question, what are the values this function's working with? So what you do is you form a hypothesis and you say, okay, well, on line 7, the value of that variable, if everything's working correctly, should be 7. So I'm going to print out the value of that variable. Hit run. Was it what I expected it? If it was, chances are your issue is somewhere else then. If you hit run and it gives you -7, you go, ooh, that's not right. So then you go, okay, well, why would it have been -7? Well, on line 5, I did some arithmetic, okay, and I multiplied it by another variable. And that other variable should have been 3. Was it 3? I'll print it out. I'll throw a print in there, hit run. Was it 3? Oh, it wasn't. Uh-oh. Why not? And you play this game. And you chase that bug with the prints as your trail. And you hone in on it, and next thing you know, you find it. Raise your hand if you've done this before. You threw prints into your code to help debug. Perfect. You're experts. Right? That's the way to do it. Prints aren't just good for the values, though. Prints can be good to show you, did a chunk of code actually run? For example, I have an if statement. Maybe it's complex. And looking and teasing out what the value of any of the things in that complex if statement is not, it's going to be a pain in the ass. The question I really have is, did that if run or not? Did the code, that code, when it ran, that if should have been true, and it should run the inside of the if block, right? So what I'll do is I'll just throw into my code a print inside the if statement that says, like, did I run? I hit run. Do I see the text, did I run or not? If I do, I know that if statement ran. And it was true and it ran. If it's a loop, and I'm like, well, this loop should run 5 times. All right, I'll put in the like, I'm running. I hit run. Did I see I'm running 5 times? Yes or no? No? Something's wrong. So the prints aren't just for knowing what the values are. It's for knowing what chunks of code also ran. So that's pretty helpful. I swear to God, if I were to go find my old hard drive with all my assignments on it from my undergrad, maybe I should do this one day. I should go and find it. You will see it full. And this isn't just for me. This might even be what you have in your assignment 1. You will probably do this too. You could go to any of the profs in CS and you ask to see their undergrad assignments. It'll probably be littered with commented out prints. Because programmers are always really like hesitant to delete a print once it's in there. So they'll be like, well, I'll just comment it out because maybe I need it again. I don't know why, but we are. It's a joke, but everyone does it. So I'm willing to bet you go through there, you'll find so many prints that are like, did I run? A lot of them are going to be full of much more colorful language. Did I run? But it'll just be commented out. One time I did get a prof contact me being like, just lighten up on what you write in your prints. Because I was getting mad, you know. When you're debugging, you get mad and maybe you use colorful language. I offended the TA, I guess. Prints. It's a great way to debug. And look, so any questions or comments about the print strategy here? Like, raise your hand if you've used it. Seriously, you've been using this. That's good. If not, think about it. You might like it. I highly recommend it. It's the easiest, most low-effort way to just kind of get a sense of what your code's doing visually. On assignment 3, here I'm going to give you a big thing. Everyone seems to hate assignment 3, even though I think it's pretty easy, but of course I know. I made it, and I'm a little more experienced. But with assignment 3, a big part of assignment 3 is so you got to make a tic-tac-toe game. And a big part of assignment 3 is formatting the output correctly. So you visually, when you hit run, you will visually see the output, right, of your tic-tac-toe game. But because it's very visual, this assignment it's not that it's designed to be tedious, but it's kind of designed to be tedious, where it's not that it's hard to get it right, but it's easy to get the output wrong if you're not taking your time. So the point of this assignment, the point of assignment 3 is really, there's a lot of points to it. You're learning a lot more. You're emphasizing references in your lists and iterating through lists and being sure things are referenced and what's a copy and what's not a copy, etc. That's a big part of it. But another big part of assignment 3 is to emphasize debugging. Because you've got a really good read, execute, print loop, or they call that a REPL. You write your code, you hit run, you see what the output is, was it right or wrong? And when you can visually check correctness, it's a little easier. You make a change, you hit run, was it right or wrong? You make a change, you hit run, was it right or wrong? So assignment 3, a big part of it, if you're getting mad because it's wrong and you have to do a lot of debugging, yeah, that's the point. But remember, that's also programming. But it's designed in such a way that it should be a straightforward debugging process because it's very visual. And you'll be able to see the effect of your change visually, FYI. Here's a function, sum up to 0. We won't have time to do it, but if you want a fun little exercise this weekend, because I all know you love this so much, try to debug this with a print. You might be able to look at this and see the problem to begin with, but if you threw print in here and you started hitting run, try to see if you can chase the issue. This one's actually non-trivial. Honestly, for an experienced programmer, it's probably easier for an experienced programmer to look at this code and see the issue than it is to use a print. But if you don't see the issue immediately, chasing this bug with a print is not trivial. This one's actually a little tricky, but see if you can get it. Any last questions before we wrap up? All right, have a wonderful weekend, everybody. And of course, if you have any questions, thoughts, concerns, you want to chat, I get lonely, come see me at student hours as always.